Okay, so we're going to do the June 2023 Further Maths AQA paper 2. I hope this is useful. To solve this, I want to get rid of the fractions really, so I'm going to multiply both sides by 3d minus 7 and I'm going to multiply both sides by 2. I'm going to do it in one go just to make it a bit quicker. So I get 2 lots of 8d minus 3 equals 5 lots of 3d minus 7. Multiply all that out, I get 16d minus 6 equals 15d minus 35. Take 15d from both sides. d minus 6 equals minus 35. Add 6, d equals minus 29. First 4 terms of a linear sequence. So linear kind of arithmetic sequence, so it's going up in 3.5s every time. So that means it's going to be, the nth term is 3.5n, and when n is 1, we're here, so 3.5 times 1 is 3.5, we've got to add on another 11.5. There we go, and then we just check that works for 2 and 3, so for 2 that'll be 7, 7 plus 11.5 is that, and 3 times is 9, 10.5, 10.5 plus 11.5 is 22. So we're all good. 2a. 2b, a different linear sequence has nth term 318 minus 9n. Work out the first negative term in the sequence. So I'm going to do this as an inequality. 318 minus 9 has got to be less than 0. Take the 9n over the other side. It's less than 9n. n has got to be bigger than 318 divided by 9. 35.3. Sorry, 35.3 recurring. So the first value is the 36th value because it's got to be a whole number. Okay, work out the value of this. So to multiply this, we go 3 times 1 and 5 times 4. And that will give me t, so 3 times 1 is 3, 5 times 4 is 20, so t is going to be 23. Then the next one, u times 1 plus 2 times 4, which is 8, is going to equal 6. So u is going to equal minus 2. So t is 23 and u is minus 2. I think the only reason they write the questions like that is just so that they can't be done easily on a calculator. I've just seen something about the previous one. So it's they want the value of the first negative term. So actually we've then got to do 318 minus 9 times 36. 318 minus 9 times 36. The value is minus 6. Okay, Question 4. Line passes through this and this, where k and r are constants. The midpoint x coordinate is that, the gradient of the line is that. Work out the value of k. Okay, so we know that the midpoint of the x coordinate, so that we know that the average of the x coordinate, so 1 plus r over 2 has got to equal 5, which implies that r has got to equal 9. Multiplied by 2, 10 minus 1, so r is 9. So we've now got the gradient, so the rise is 6 minus k over the run, which is 9 minus 1, has got to equal 2. This is 8, so 6 minus k over 8 has got to equal 2. So 6 minus k is going to equal 16. Take k over the other side. 6 minus 16. So k has got to equal minus 10. Okay, work out the value of x for which the rate of change of y with respect to x is. So all that is saying is dy by dx. So dy by dx is the rate of change of y with respect to x equals 4 times 0.5 x to the 3. In other words, 2x to the 3. And we need to know when 2x to the 3 equals 6.75. X cubed equals 6.75 divided by 2. .375, and x is the cube root of that. .5. Okay, equation of circle is this. The coordinates at the centre, well, we can just read them off. It's actually in the formula sheet for this book. Is minus 7 for the x and 4 for the y, and the radius is 6 because it's written in that format. Here's the sketch of the curve. Curve intersects. Turning point at x is 0.5. So I think the easiest way to do this is to think of the symmetry of this. And now if you've got the turning point, then this one is just going to be at 4.5 bigger than this, so it's going to be at 5 because that's 4.5, and therefore that by symmetry must be 4.5. So the value of p is 5. Solve when that is bigger than 0. So it's bigger than 0 when x is bigger than 5 and x is less than minus 4, because it's this bit and this bit, yeah, and between the two it is less than 0. Okay, work out the size of angle W. B to D, D to C is in the ratio 2 to 3. We know the area is 25, so the area equals 25, which means that 4 times if I say the whole length is x, then 4 times x over 2 equals 25, which means times by 2 divided by 4, or 2x, so x is 12.5, and then I've got to divide that 12.5 in the ratio 2 to 3. So I divide that 12.5 by 5, so I've got 2.5, so I've got 2 to 3, and the total is 5, and we've got 12.5 to divide, so we've got to multiply each of those by 2.5, so it's 5 to 7.5. Which means this is 7.5, which means now to work out W we do tan to the minus 1 opposite 4 over 7.5. Is 28.07. Let's go to 1 decimal place, 28.1 degrees to 1 decimal place. Okay. Question 9. The total length of all the edges, all the lines, is 300. Show that that is true. Okay, so we know that, well, there's 4 times 3x plus 4 times 2x plus 4 times x plus 2y, and that's got to equal 300. So I'm hoping that if I rearrange this, I've got 12x plus 8x plus 4x plus 8y equals 300. So I've got 24x, so I've got 8y equals 300 minus 24x. Divide it all through by 8, or let's divide it all through by 4, because everything divides by 4. I get 2y equals 150 is 75, divided by 4 is 6x, which means that y equals 75 minus 6x over 2. The volume of the cuboid, show that the volume is that, so the volume equals 2x times 3x times x plus 2y, which is 6x squared x plus 2y, which equals 6x cubed plus 2, let's call this 12x squared y, and y is 75 minus 6x over 2, so let's call that 6, so is 6x cubed plus 6 times 75, 450, x squared minus 36x cubed. So altogether we've got 450 x squared minus 30x cubed. Use calculus to work out the maximum value of v as x varies. So we want to see when dv by dx equals 0, when dv by dx equals 900x minus 90 squared. That is maximum when 0 is 900 minus 90x squared. Well, it's not when x is 0, so let's divide by 90 and x. So we get 0 equals 10 minus x. So x equals 10. And we want to find the maximum v. So v, when x is 10, v equals 450 times 100 minus 30 times 1,000, which is 15,000. Okay. Question 10. Line K has equation this. Line L passes through these. Work out statements about K and L. Okay, so it's all about gradient, so let's rearrange these to get the gradient form. So if I take the 5x over the other side, I get 4x minus 17 equals 5y. Then divide through by 5 is 4 over 5x minus 17 over 5. And then L, the gradient of L is the rise, which is 16 minus 6, which is 10, over the run, which is minus 5, is minus 8. So this is minus 5 over 4. So we've got a gradient of 4 and 5. Okay, and we can see that they are the negative reciprocal of each other, or we can just show 4 over 5 times minus 5 over 4 equals minus 1, therefore perpendicular. So they're perpendicular. There we go. First line of questions. Next one, question 11. Expand and fully simplify. Okay, so we've just got to multiply everything out. So we get 6x to the 5 plus 2 times 4, which is 8x cubed, minus 9 times 3 is 27x squared, minus 36 plus x squared, plus x times x squared minus 8x plus 16. So we've got 6x to the 5 plus 8x cubed minus 29x squared minus 36 plus x cubed minus 8x squared plus 16x. So So altogether we've got 6x to the 5 plus 9x cubed minus 37x squared plus 16x minus 36. Doesn't look very nice at all, but that is as simple as it goes. That's 27. 27. 8 is 35. Apologies. Okay, question 12. Work out the size that the angle VA makes with ABCD. So VA is that line, makes with the plane at the bottom. So the way you need to do this is you need to look at the line that is directly underneath that. So we're going to look at that one, and then we're interested in that angle when we're talking about a distance between angle between a line and a plane. So we need to work out the length AX, and then we're all good because we've got the diagonal length there. So the length AX, well, if this is 15 and this is 15, we can work out the length AC. So I'm going to say AC is the square root 15 squared plus 15 squared, which is 21.21320, which means that AX is half that, which is 10.6066, which means the angle that we want is angle VAX. We've got adjacent hypotenuse, so we've got cos VAX equals adjacent 10.6066 over the hypotenuse, which is 28. So cos to the minus 1. We get an angle of 67.7 degrees to 1 decimal place. Okay, question 13. Circle the expression equivalent to that. Okay, this is really important. The 3 is on the top, and the x to the minus 7 means the x to the minus 7 is on the bottom, and it's not negative. So it must be that one. If you've got this wrong, please check this. It's absolutely crucial. Okay, simplify this. So this is going to be 12w to the 8, and then we've got to square this bracket. So this is over 16w to the 6, which means we've got w squared, and we've got divided by 4, we've got 3 over 4. So I think this I would write as 3w squared over 4 as our simplest version of that. And work out the least possible values of C and D. So we've got y to the power half times y to the power third equals y to the power d over c. So add those together, we've got a half plus a third. So that's 3/6, that's 4/6, 3/6, 4/6, 5/6. So y to the power 5/6 equals y to the d over c. Well, 5/6 is the smallest fraction, so the smallest values of these, c is 6 and d is 5. Okay, so simplify fully. So first thing I'm going to do is I'm going to see that that's 5. That a goes with that a squared. So I'm just left with 5a on the top there. And then I'm going to factorise the bottom. So I've got 5a, and this will factorise as well. 5a times, let's take a 4 out of this, 4 times 2 minus a, and then I'm going to factorise the bottom, a plus 8, a minus 2, gives me minus 16 plus, x, a. Okay, a minus 2 and 2 minus a. So other than a minus sign, they're all good. So on the top, I've got minus 20a. And on the bottom, I've got a plus 8. That will be as simple as I can get that. Okay, question 15. The domain of the function, so there's the inputs, is x is minus 1 to 2. P is that, Q is that. Work out the range of the function. Okay, so to do that we're going to need to work out a and b. So we're going to have some points, so we've got, when it's 0 it's a half, so a half equals a times b to the 0. B to the 0 is 1, which means a is a half. And then the other one is going to be, the other point we've got is point Q, when it's 1, it's 3 over 2. So 3 over 2 equals a half times b to the 1, which is just b. So b equals 3. Multiplying both sides by 2, which means our equation is a half times 3 to the x. So when x equals minus 1, y equals that's 6, and when x equals 2 to its maximum, y equals a half times 3 squared, 9 over 2. So the range then is between those two. This is the function g of x. So the range is g of x is a sixth less than or equal to g of x less than or equal to 9 over 2. Because it equals at both ends. Okay, 16. 2 minus 3x is a factor of this, solve this. So it's a factor, meaning 2x minus 3. And then I know it must be 3x squared. And then I know this must be plus 2. So I've just got to work out, so this will be 6x cubed minus 9x squared and I want 25, so I've got to have minus a few more x squared, so I've got to have minus 9, I've got to have another 16, it's minus 8 x, that'll give me minus 9x squared minus 16x squared, which is minus 25x squared, minus 24x, sorry, plus 24x plus another 4x is 28x, so that's all good. And then I've got to fully factorize this. 3. Now that it says as exact values is slightly worrying me, but this maybe doesn't factorize nicely, but let's just see. 3x going to be minus 2 and minus 1 if it does to x, so that's going to be, let's make it the other way around, 2 and 1. So it's going to be plus 2 minus 6x minus 1x is 7x. Okay, so it doesn't look like it factorizes. So that means that x has got to equal minus b, which is 8, plus or minus the square root of b squared, which is 64, minus 4 times a times c, all over 2a, which is 6. So we've got 8 plus or minus the square root, 64, 12 times 64 minus 12 times 2 is 24, it's 40, square root of 40, 6. So I'm going to divide everything through by 2. So it's going to be 4 plus or minus the square root of 10 over 3. And x equals 3 over 2. So those are the two solutions, 3 over 2 and 4 plus or minus the square root of 10 over 3. Okay. 16, question 17. The function is given by that, where h is an increasing function for all values of x. Okay, so if it's an increasing function, then dh by dx must be bigger than 0. So let's just multiply this out. H equals 3ax cubed minus 2ax plus 5x. dh by dx therefore equals 9ax squared minus 2a plus 5. And we're working out when this is bigger than 0, So this has got to be bigger than 0. Sorry. Bigger than 0. 9a x squared minus 2a is 5. So x squared is always bigger than 0. So as long as a is bigger than 0 and minus 2a plus 5 is bigger than 0, then it definitely will. So that's 5 is bigger than 2a. A 5/2. So a is less than 5/2, but a also has to be bigger than 0. So I think it'll work. Everything in that range. A is positive, so we know it's bigger than 0, so it's got to be less than 5/2. Okay, question 18. Closing in. Okay, here's a sketch of cos x. A is an obtuse angle measured in degrees, where A equals minus k. Yep, as shown on the diagram. 2 boxes show expressions for where x equals, tick 2 boxes, cos x equals minus k. Well, it repeats itself every 360. Okay, so it's definitely going to be 360 plus a, but it's also going to be there, which is 270, 360 minus a, because a is that distance, which is the same as that distance, so it's 360 minus a. Okay, these simultaneous equations, k is positive, solve the simultaneous equations, give the answer simplest form in terms of k. So, in terms of k, so if we sub in, get 3x plus 4 times y, which is 2kx equals k. Then if we take x out as a factor of this, we've got 3 plus 8k equals k. So we know that x equals k over 3 plus 8k. Can't get it much simpler than that. And then y is 2k times that, times k over 3 plus 8k. Which is 2k squared over 3 plus 8k. And again, can't get that much simpler. Okay, question 20. Show that this simplifies to that, where p is a constant. So we know, the two facts that we know is we know that tan x equals sine x over cos x, and we know that sine squared x plus cos squared x equals 1. So the first thing I'm going to do is I'm going to get rid of the tans and then see what happens. So this equals 2 sine cubed x plus 2 sine x cos squared x plus 5 sine x over cos x times cos x. That's 5 sine x. And here, I think if I take a sine x, if I take 2 sine x out, I'm going to get sine squared x plus cos squared x plus 5 sine x. Now that sine squared x plus cos squared x is 1, so I get 2 sine x times 1 plus 5 sine x equals 7 sine x. Okay, that's question 20. Closing in. 2 questions to go. Question 21. To work out the value of x. So, not obvious. Let's just write in what we know. So we know that that's going to be 2x. So we know that that is going to be 180 minus 4x, because those are both radii. We also know that the angle at the centre is twice the angle at the circumference. So we know that all the way around there is 14x, which means here is 360 minus 14x. Which means that, kind of by similar logic, this is 360 minus 12x. Which means we've then got a statement that all adds up to 360. So we've got 180 minus 4x plus 360 minus 14x minus plus 360 minus 12x equals 360. So let's take all the x's over to this side. 12 is 26, it's 30x, and then the 360 is here. We've got 180 plus that, so we've got 4, 5, 40 is 30x, so we've got x is 54 divided by 3 is 18. What a lovely question that one is. And final question, question 22. There are, for each integer, all the digits are used exactly once. The integers are greater than 400,000 and odd. How many different integers can be made? You must show your working. So, they must be they must be greater than 40,000. So they must begin with a 7, an 8, or a 9. And they must end in a 1, a 7, and a 9. Yeah. So, starting with a 7, we've got 2 ways. Two ways we can get the last value. And then there's 3 values in between. Isn't there? 1, 3. So there's 3 times 2, and then the last one's fixed. So starting with a 7, there are 12 ways. Starting with an 8, there are 3 ways you can get the last value, and then you've got 3 times 2 there, and then starting with a 9, it's the same as the first one, 2 times 3 times 2. So there are 12 of these, there are 9 times 2, 9 times 2 is 18 of these, and there are 12 of these. That means altogether there are 42 ways. Okay, we might need to do a bit of work on that to talk about how that is. Okay, I hope that has been useful.